Hello, good morning. Let's see, I'm just getting ready here. I got this, I was just going to tweet out about the episode or the session. And then I got stuck in Twitter. That happens. By the way, I did this podcast with Pedro from Modules. Yeah, about stitches and stuff. It's more about modules than stitches, kinda. But it's interesting to see how stitches has been helping them to deal with this stuff. Anyways, and then I got this other tweet about yesterday's episode, and it's really cool. There's a guy who actually experimented with Mobex and Inversify. So that's awesome. I just wanted to answer him first before we go into our week planner and continue our refactor. Let's bring up my... This strategy has gotten you'll be intrigued. Yeah, I was yesterday. I was working on this side project based on like the visual part of what I was talking about yesterday, and I'm actually into reading ASTs and stuff like that now. So it should move pretty fast now, at least to the point where I can actually show it off, and you can see, you can actually see the concept. Yes, blah blah blah. And let's see here. Oh, aren't we getting any types now? We did a change on the type fetcher yesterday. Basically, as I said, we have no idea what's happening with the type fetcher, so we exposed an API endpoint so that we can look at what's happening inside type fetcher as it's working. And our goal is to kind of get proof that it's not cleaning up after itself. But nah, okay, there we are. Awesome. Yeah. So I'm like checking this endpoint from time to time to see if we have any old folders lying around. Anyways, let's remove, we don't have strict mode anymore. I'm just going to go through this quite quickly. Well, I typically stop and start talking about something, but anyways, let's, as we mentioned, there aren't any changes to the actual definition of the state machine. It's more, let's see, the actions needs to deal with it. So there's no change to the transition, that's the same. That needs to be a method, but what we changed is how we do matching. So what we'd rather do is we check if we actually have, yeah, this is what was wrong last time. We were checking, so we were not supposed to be able to, let's see. Yes, so we should not be able to point to, let's see. Yeah, now it says, yeah, here it is, or it can be null. This is the thing we want. So we can't point to authenticated app because it might be null. So we want to point to, if we actually are authenticated, then we can go in and do the transition, right? State of authenticated. So one one thing I see after we made this change is that some of your state transition names might be a bit long. So you kind of get these long, what's it called? Dottings. What's it called? Property access, whatever. I'm calling it dottings. Dottings into your state, which is not ideal, but at any point you can like create something like we did before, right? Something like that. So we're not going to care about that now. We just want to get the general feel of how everything works. So if we are authenticated, we are going to do this thing. State.authenticated. Oh yeah. And then if we actually transition, oh, this is interesting. So now we can actually bring these two together. So if we do, if we are authenticated and we are able to transition, let's see if we can do this. Okay, now I messed up here. Okay, there we go. And then we have to, yeah, this is an async action. And then we want to say state.authenticated. Oh, I see one thing it doesn't deal with though. That's interesting. I thought null checks actually, that's weird. Why does TypeScript, yeah, so this is kind of funny with TypeScript. Why, so let's, I'll show you what I mean. So if I do state authenticated, it's like I can't point to anything because it might be null. But if I do state authenticated, I can point to authenticated app, right? Yeah, it's just auth state like that. Yeah, by the way, what's also kind of cool about, oh, you know what? You can even write it like this, which is you get the null check for free. That's also really, really cool. And you can get that like nested as well. Yeah, I like that. I really like that. Yeah, so we can, oh, maybe we can even just do, can we do this? Oh, that's bad. That's too bad. That's too bad. Yeah, why does it actually complain about that? Yeah, anyways. Where were we? Yes, so what I wanted to show you is that, okay, so we do this check and now we actually have the auth state. Awesome. But if I were to do just something simple that we know is synchronous, I would not be able to do authenticated app anymore. You see that? It inserts this thing because now we're in a callback and like TypeScript doesn't know that this callback is synchronous. So, which means that you might have lost, like it might be null again because it might be async. That's the way I interpret this. But why doesn't that happen here? Like TypeScript knows that I'm awaiting, meaning I'm like definitely doing something async, but now it's perfectly okay. So I wonder why that is. It doesn't make any sense to me. But to me, this seems to be like something that TypeScript needs to fix. I think I'm going to create an issue on that because I find it very weird. Because here we really should do the same. Like we should have this check again. Yeah. God damn it, that's annoying. So if, yeah, this is interesting. Okay, yeah, because we're waiting here, blah. Yeah, we could kind of force it inside a callback. But yeah, I'm going to check this. I wonder if the, maybe we can search for it. TypeScript, await null check. blah blah blah. I'm not sure what to search for. TypeScript await. Null check, not resetting. I don't know. Yeah, type cards are not reset after awaiting a promise. This is the thing I'm talking about. Okay, let's blah blah blah. Async await type checks change after await. Expect 2 errors. One in test after await at MS type number, and another in test in the callback of the delay promise at MS type. Only the second error is showing up. Yeah, right. Only the callback. Commenting out blah blah blah. In short, the issue seems to be that after an await, any type narrowing checks that occurred before are still in effect, which can cause problems if the variable changed to something else. Yes. Isn't this just more or less the same thing? Okay, so they're kind of blaming it that this can happen with synchronous code as well. Well, yeah, that's true. However, the biggest difference I can see between them is there are two different ways to do basically the same thing. Wait. Anyway, I'm happy to let this. It's probably the best place to look at this discussion. It's more akin to outer and inner function rather than before and after function calls that might have side effect. This worth putting behind the flag. Okay, let's just quickly check this other thing. Just to understand. Blah. Oh, this was a long one. I typically go to the end to see like, are there any conclusions? Oh, yeah, this is probably pointing into a bunch of other stuff. To do something with it. The current situation with the wait is not invalidating type, narrowing it is quite severe, as it allows to easily trigger runtime errors when there are many async functions dealing with the same object. Yes. Note that while invalidating each type after wait feels like hard to use for the end user, the issue is easily solved by what Flow already proposes. If you need to work with some value of the object which might be invalid, simply say, say the reference and be with it. Which I interpret as, okay, if you're doing anything async, you would like do this. Auth state authenticated, and then you would do this instead. Because then you you still operate on the, you have a reference, and then, yeah, this is interesting. But this is not, for me, this is like, it would be nice if this was handled by the API somehow. Because now what happens here now is that if app has been disposed because we've changed, we're not in the authenticated state anymore, the transition just doesn't do anything. Yeah, this is interesting. This is very, very, very interesting. Yeah, so you don't really have any protection against await. So this is kind of, yeah, this is interesting. So actually doing callbacks in TypeScript is way safe, like for asynchronous code, is way safer than using async await. Because at least the callback hell invalidates the typing, which await doesn't. That's very fascinating to me. That's crazy. Okay, if state authenticated. Oh yeah, and now we can, this is nice. Now we can put these two back together, and if state of, yeah, and we can even, dot app. Yeah, how do we actually do this check? That's interesting. I guess we can do Once app state. Should we do? I guess we can do this. Yeah, I guess we have to explicitly do this, or we're in edit current week, or we're in app state. Oh, come on. Plan next week, then do this thing. Oh, did I do something wrong? No, it's okay. Yeah, because we can't really... wonder if there's a better way to test this, multiple ones. It looks pretty good though. It's very clear. Might say it's a little bit boilerplatey. Oh yeah, Etienne, sorry, I saw your comment now. I guess after diving into the discussions there, it doesn't seem like they consider it a bug, but I would definitely consider it, well, not necessarily a bug, but a huge flaw in async await in terms of type safety. It's crazy. Like, you can't trust any types after an await. That's basically it. You can't trust it. Which is, I have to write a tweet about this. Why are we not? Let's see. I am curious. I am curious. Why are we not concerned about TypeScript not invalidating types using async await? I feel forced to use callbacks instead. After using async. I feel forced to use callbacks instead. Why are we not concerned about this? Is a nice, I'm not like being too, I start with I am curious, like not being what the hell are you doing, but yeah, I think this is a nice tweet. I kind of go through my tweets like 3-4 times, making sure I'm like balanced so it doesn't come off as me being an asshole. But still, like, this is, I feel this is important. I feel forced to use callback for all my async code. Yes, hopefully that we'll get some feedback on that. Yeah, that was pretty mind-blowing to me. Okay, so we have the same thingy here. Blah, we'll just do this. Just do that. And then app state. Oops. Yeah, but I like this little quirky thing. That's really nice. Or could we even... No, I guess we can like... Oh, wait, we can do this, I think. Can we? Or... No, it would have to be like app state and yeah, anyways. But why do I have these? Do I have to have these? Yeah, I do, because this might be null. Or, yeah, that might be null. Let's see. But event callbacks won't solve it completely, because as you need a sync call, sync call could change mutate to, though I think it never have been a problem for me because I work with a mutable object, which can eliminate the problem entirely. Yeah. Yeah, like synchronously it could suddenly change as well. That's true. That's very true. I guess it's about, yeah, I guess the argument is making the best out of it. Like, yeah, you can never fully control it, but it's more about like trying to help as much as possible, I guess. Because at least that's typically where you things goes to shit, is when you do something async. But yeah, very good point on immutability. That's a very good point, because you don't have to deal with that stuff. Though you kind of, I guess you kind of pay with it in, like the API is very different. It's very interesting how when I get feedback on Overmind, people kind of ask, is it immutable? Which is interesting, because if you do something like this, foobar, if you see the syntax in the context of just a function, it's, and even if you do like await blah blah blah, and then something like this, like it can't be immutable. That's what immutability does to your code in terms of state changes, is that you have to return. So you can write code like this, but you cannot have anything async, and then you have to return the new thing. So like immer, for example, you would have like a draft here, and then you could kind of mutate it, but then under the hood you actually create a new object, which you have to, well, you don't have to return it, but implicitly it returns it. My point is that with immutability, you're forced into making all changes like through a function which returns something new. I'm not saying that's a bad thing, but it doesn't allow you to have the straightforward code you have in an action, like in Overmind, just doing the state changes, doing the async stuff. So I guess it's like with all things, it's a trade-off. But I did try to explore once to use immer, and still being able to write it. Yeah, I actually have a project on this. So you actually write your code just like this, and it looks like you're mutating, but actually under the hood it's immutable, which is interesting. But you still have this straightforward way of writing things. Maybe we can look at that at some point. If you call another effect that does a transition, TS won't understand. Oh yeah, with state machines, you don't really do direct mutations. It depends on how, yeah, this is a good point, because, and this is a really good point, because when I looked at state machines, like when we do a transition, this is a really good thing to talk about, because I thought a lot about this. So when we do a transition like this, ooh, what the hell? What just happened? Hey. Hello. What the hell just happened to my screen? Oh, there we go. So if we do a transition like, do we have, yeah, unauthenticated. This makes a ton of sense, right? You're not directly mutating it. It's happening under the hood, which could be immutable. But what if you have a list of to-dos? This is the thing with state machines. So if you were going to have it immutable, and this is what you see in XState, at least this is the way I interpret it and think about it. if you want to add a to-do to the list, you actually have to create a transition state for that. So for example, add to-do, and then you would have to, using the same API surface here, you would have to say like to-dos, and you might have to do something like to-dos, like state, something like this, state to-dos concat, and then you have a reference to the new to-do outside here, for example. So you would have to do something like this to do that change, because it needs to be immutable. But in this case, we can just check if, so it's not only that you have the crazy ass immutable way of, sorry, this shouldn't be to-dos, of course. Sorry about this. I'm just trying to make a point here. So you have to do this immutable way of describing the change. But yeah, like how would you do this? So add to do, you can't change, I guess this works. Anyways, but the thing is, it's not only that you have to express it immutably, the change, and you could use immer here, of course, but you also have to have an explicit transition state to actually do that. While in this case, you can just say if state list, for example, whatever that state is, you're safe to just say state list to-dos push and then the to-do. So I think that's just a way more natural way to do it, because one thing is if you didn't have to add this transition state, which then when you transition into it, it changes the state and then it moves out of that transition state again back to the list, for example. But if you're going to do all your state changes through a transition, you have to create these additional transition states only to change the state. Well, you don't have to do that in this case. And I guess you can argue that this is a good thing, but I think it's harder to think about state machines when you have to have these intermediate states only to mutate state or change the state. I believe you can get away with just the first layer being immutable. Oh, that didn't quite come. I know it's difficult at the end. I'm like talking and having code in front of me, and you only have the Google chat. It's not ideal. Yeah, sorry if I'm not understanding it correctly. But yeah, so this is kind of the thing I identified looking at like an immutable state machine and having a mutable one. And this is generally, like with the mutable code, you have more straightforward syntax, arguably. But for sure, you have safer code when it's immutable. Yes, I would never argue with that. Oh. Sorry about that. Let's see, working from home, both of us. Let's see, state authenticated. Let's just get this thing done first and foremost. What are we doing here? We're doing state authenticated profile. Yeah, API design is super tricky. One thing is if you work in a language that kind of has settled all of this, is it an immutable language, for example? And like in JavaScript, we have to deal with all this underlying stuff. So either do you want to be mutable or immutable? Do you want to, I don't know, want to use classes or you want to use functions? Like we don't only have, in other languages, these things seems a lot more settled. So for example, C# is like object-oriented, class-based. And then you have a completely different language like F#, which I guess I never use it, but I think it's like functional and immutable. It's kind of, yeah, but in JavaScript you have both of them, or we practice both of them in the same language, which makes it insanely hard to create APIs. All right, now we can do this thing. App, was it add backlog item? Oh, that's nice. That's a nice one. And then if we have a description, oh yeah, so we really want access to our app state authenticated app. App state. Oh yeah. Oops. Why is this yelling? Oh, maybe I did something wrong here. Oh, add backlog item, add backlog item. Oh, I think I was supposed to make this app. Yeah. So this is the cool thing now. I can make the whole thing a state machine. So instead of instead of having like an object of different states, I can make the whole state of a specific transition state a new state machine. We just have to make sure that we handle this up here as well. Yeah, let's see, where do we actually activate this thing? Oh yeah, here we have it. So instead of doing this, we're going to do this. We transition to add backlog item and we create a state machine on that state. That's what we want. So that we don't have to do this anymore. Oh, sorry. Add backlog item. Cool. We don't need to return anything anymore. Well, I guess we do need to return here. Let's do an else. Let's do an else. Yeah, maybe we could put these two together. I don't know. No, let's just keep it like that. And where are we at now? Oh, did I do something wrong? What are you? Oh no, I think it's just complaining. Oh, by the way, I totally forgot to mention this runtime error. Our runtime errors are reflected in the code, but when you have types, it doesn't understand the typing. So it shows you the runtime error at the wrong spot in the code, which can be confusing. We have to do something about that. Like, it's pretty cool that you can see runtime errors in your actual code. Like, these are one of these hidden things about Codesandbox that you kind of don't, if you were to think about Codesandbox as a concept before it was created, you wouldn't typically think that, oh, if we do that, we'll be able to show runtime errors in the actual code. This is something you discover when you start building it. But then again, it's like, it's a new thing. You have to make sure that it isn't confusing. Anyways, I have some syntax error here somewhere. Where did I go wrong? Okay, let's see what happens when I do this. Okay, yeah. Okay, so this is going to be an interest. Let's refactor. Like, I can't. I said I was just going to go through this, and I started talking. Typical. Okay, we're almost done, but I won't be able to finish it now. But let's do this one, and then we'll finish the rest tomorrow. And I think that's a good spot to evaluate, because it's Friday, and then I can release a new version of Overmind over the weekend, because I really need to get that out. And then I can play around with this new concept over the weekend, and hopefully I have something to show you after a weekend. I actually did my first AST thingy yesterday, and it's really, really cool. Like, just going into the code, finding like nodes, or what they call it, like statements and stuff, and then translate those into like visual node links, which is crazy. And it actually works. It's really, really, really cool to see it working. Anyways, let's get this done. Authenticated and app. Was it add backlog item? Yeah, and then we want to know if this, let's see, add backlog item state. So if it's error or invalid or valid, then we want to do this stuff. Cool. It does look like, syntax wise, it's very, very clear what we're doing here. And I'm surprised that how quickly I kind of naturally created this. Maybe that's way too detailed, but I created this variable without kind of thinking about it, because I wanted to do this nested matching. I don't know. That's a good thing. But yeah, it does look really, I don't know. What do you think about this? Does it seem clear to you what's happening? Yeah. Anyways, we'll evaluate this tomorrow. And I think it's easier when everything's refactored and we can take a look and we can talk about how things work, how it looks. And like, as I mentioned, there's been a journey here. We tried many different things and they've all had like serious concerns in terms of getting the typing to work. Like we went through callback hell. We even didn't have the possibility to transition and setting the state at the same time. So we didn't have safe transitions, which is fixed now. So yeah, just like we're talking about immutability and mutability, like you can't find a perfect thing, because everything has like seems at least to have like one negative consequence. So you kind of have to balance out what you're trying. And for Overmind, I think since it's mutable, we need a mutable state machine, because then it also fits better with the actions, so that you can do these more straightforward mutations on the machine, as long as you check that you're in the correct state first. And we are forcing you to check that now, because all of the states are null. The only thing that we don't really deal with now is more of a general thing in TypeScript, which is the async stuff, like async await. But yeah, you could. Yeah, exactly. I guess that's what you meant, Etienne. Like you could do two transitions synchronously as well. Yeah, exactly. And that wouldn't help you either, I guess. Yeah, like you could grab app state here, not like, let's say you're transitioning here, and then the app state would kind of be wrong. I don't know. My brain broke thinking about that. Anyway, so let's get this done tomorrow morning, and then hopefully we have something that at least we can release. And I don't want to have this feeling I could spend forever on this. And maybe we'll go ahead and make some changes later, but I really don't want to make any more breaking changes on this API. Especially since we've been through so many iterations. So I think we've found the best way to deal with this. Anyways, I'll think on that, reflect on that, and then we'll talk more tomorrow. Bye. Finish.